NEC 110.40 mandates that electrical conductors must be sized to handle the maximum current that could potentially flow through them under all possible conditions. In a scenario of undersized jumper cables within an electrical panel, even though downstream circuit breakers are in place to limit current flow, a hazardous situation can arise. Consider the event of a fault occurring on a downstream circuit. In such an event, the upstream breaker may not trip rapidly enough to prevent an excessive amount of current from coursing through the jumper cable. This can lead to the jumper overheating, which poses a fire hazard. To ensure safety and code compliance, NEC 310.15 V6.1 provides specific guidelines for sizing jumpers connecting bus bars or breakers. These jumpers must be sized to match the ampacity of either the bus bar itself or the ampacity of the larger circuit breaker or fuse that they connect to. Therefore, demanding proper sizing of these jumpers is not a code violation, it is an essential safety measure. The counter-argument that downstream breakers will inherently limit current does not fully address the potential for overheating and fire, especially in the event of a fault. The conductor must be able to carry the available fault current until the overcurrent protective device opens the circuit. Undersized conductors will be the weak link in the system and can cause a failure. The available fault current in a system must be determined by a qualified person. This fault current is typically much higher than the normal operating current. Firstly, NEC 110.14 addresses the issue of electrical connections, requiring that splices and connections be suitable for the application. This includes ensuring they possess adequate mechanical strength, provide durable electrical contact, and are enclosed or insulated properly. When dealing with connections within a panel, especially those involving jumper cables, it is essential to ensure that these connections meet these requirements to prevent failures, overheating, or arcing. Secondly, NEC 240.4 focuses on the protection of conductors. It stipulates that conductors shall be protected against overcurrent in accordance with their ampacities. This means that the overcurrent protection device, such as a circuit breaker or fuse, must be selected to protect the conductor from overheating due to excessive current. When jumper cables are undersized, they may not be adequately protected by the upstream breaker, especially under fault conditions, leading to potential damage or fire. Thirdly, NEC 310.15 provides guidance on determining the ampacity of conductors. This section details the allowable current carrying capacity of conductors based on factors such as conductor size, insulation type, installation method, and ambient temperature. It is crucial to consult this section to ensure that jumper cables are sized appropriately for the expected current load and environmental conditions. Fourthly, NEC 408.36 and 408.55 pertain to overcurrent protection in panel boards. These sections specify requirements for the number and arrangement of overcurrent devices within a panel board, as well as the need for proper labeling and identification. When modifying or upgrading a panel board, it is important to ensure that these requirements are met to maintain safety and compliance. Fifthly, NEC 110.3 B emphasizes the importance of following manufacturer's instructions. Electrical equipment, including panel boards and circuit breakers, should be installed and used in accordance with the instructions provided by the manufacturer. Failure to do so can void warranties, compromise safety, and violate code requirements. Sixthly, NEC 310.15 8.3 addresses the issue of conductor ampacity correction factors. When conductors are installed in conditions where the ambient temperature exceeds 30 degrees Celsius or 86 degrees Fahrenheit, or when multiple conductors are bundled together, it may be necessary to apply correction factors to the conductor ampacity to account for the increased heat. This is important to ensure that conductors do not overheat and cause a fire. Seventhly, NEC 110.9 deals with interrupting rating. Equipment intended to interrupt current at fault level shall have an interrupting rating sufficient for the nominal circuit voltage and the current that is available at the line terminals of the equipment. Equipment shall be marked with its interrupting rating. This is especially important when dealing with electrical panels. Eighthly, NEC 110.10 concerns circuit impedance, short circuit current ratings and other characteristics. The overcurrent protective devices, the total impedance, component short circuit current ratings, and other characteristics of the circuit to be protected shall be selected and coordinated to permit the circuit protective devices used to clear a fault to do so without extensive damage to the electrical components of the circuit. This fault could happen on the jumper itself. Ninthly, NEC 250.24. 8.1 states that the grounded conductor shall be connected to the grounding electrode conductor and grounding electrode at any point in the supply side of the service disconnecting means. This ensures a proper ground. 10thly, NEC 408.3. It requires that all panel boards shall be durably marked by the manufacturer with the voltage and the phase. This information must be visible after installation. In summary, the contractor is incorrect in asserting that the downstream breakers eliminate the need for properly sized jumper cables. The NEC prioritizes safety and requires conductors to be sized to handle potential fault currents, not just normal operating currents. Therefore, requiring the contractor to replace the undersized jumpers with properly sized ones was the correct course of action and ensures the safety and reliability of the electrical system. The argument presented does not adequately address the potential dangers that could arise due to overheating and the risk of fire in the event of a fault. Ensuring the electrical system's safety necessitates taking this action. Consider a 225 amp main breaker feeding a panel with a 6 AWG jumper connecting to a 50 amp breaker. During a short circuit on the 50 amp breaker circuit, the 6 AWG jumper could overheat and potentially melt before the 225 amp main breaker trips. This is because the 6 AWG wire has a much lower ampacity than the 225 amps that could potentially flow through it during a fault. The National Electrical Code, specifically Section 310.15, b 6.1, addresses this situation. This section mandates that jumpers between bus bars or breakers must be sized to handle the ampacity of the bus bar or the largest circuit breaker or fuse they connect to. In this case, the jumper should be sized to handle at least 225 amps, matching the main breaker. While downstream breakers do provide protection for their respective circuits, they cannot protect the jumper itself from overcurrent in the event of a fault occurring before the downstream breaker. It is also crucial to remember the importance of proper installation and termination of conductors. Even if the correct wire size is used, loose or corroded connections can create hotspots and lead to overheating and potential fires. The NEC also addresses this in Section 110.14, which requires that all electrical connections be made in a professional and workmanlike manner. The contractor's argument that the downstream breakers would limit the current on the jumpers is only partially correct. While the downstream breaker will protect the circuit it feeds, it does not protect the jumper itself from fault current. The NEC prioritizes the safety of the entire electrical system, including the conductors themselves. Therefore, requiring the contractor to replace the undersized jumpers with properly sized ones was the correct action to take. In addition to the code requirements and safety considerations, there are also practical reasons for using properly sized conductors. Using undersized conductors can lead to voltage drop, which can cause equipment to malfunction or operate inefficiently. Voltage drop is the decrease in voltage that occurs along a conductor due to its resistance. The longer the conductor and the higher the current flow, the greater the voltage drop will be. Properly sized conductors will minimize voltage drop and ensure that equipment receives the correct voltage. Furthermore, using properly sized conductors can improve the overall reliability of the electrical system. Undersized conductors are more likely to overheat and fail, which can lead to power outages and equipment damage. Properly sized conductors will operate cooler and last longer, reducing the risk of failures and downtime. Therefore, there are numerous reasons why it is essential to use properly sized conductors in electrical systems. The NEC requires it for safety reasons, but it also makes practical sense to ensure the reliability and efficiency of the system. The contractor's questioning of this action is unfounded and demonstrates a lack of understanding of the NEC and basic electrical principles. The decision to require proper sizing of the jumpers was justified and in accordance with the NEC requirement. This contractor's argument is not valid because it does not address the potential for overheating and fire in the event of a fault. In conclusion, your action was not an NEC violation. It was actually a necessary step to ensure the safety of the electrical system.